Good afternoon, or good morning, or good evening, depending on where you are listening today. Thank you all for joining me today for the 19th of our Colombia CBIPS lecture series on the AEC experience relating to COVID-19. This is our series finale, and we are really pleased for having you here. I'm Fenioski Peñamora, Executive Director of Colombia Center for Buildings, Infrastructure, and Public Space, and Edwin Howard Armstrong Professor of Civil Engineering and Engineering Mechanics at Columbia's Full Foundation School of Engineering and Applied Science. As the events of the last months have demonstrated, we are living during exceedingly challenging times, characterized by divides, distrust, and distancing. However far apart we have been, however far apart we currently are, we need to learn to come together, to be together, to act together for social, economic, and environmental justice. I hope that the events of these days bring better understanding of the injustices that exist and become a catalyst of bringing about real change for all. Along with my colleagues in New York City and around the world, the faculty and staff of the Center for Buildings, Infrastructure, and Public Space would like to add our voices to those decrying institutionalized racism in the AEC industry. Today, our industry has a challenging work ahead to achieve true racial and gender inclusion. We need to stand together with our Black architects, Black engineers, Black contractors, Black suppliers, and Black community. We need to listen better, to learn better, and to incorporate the lessons of diversity and distress into the way we, all working together, reshape economically challenged communities. We need to build a better future for our industry, characterized by respect, opportunity, and collaboration. Our lectures have brought people together to address the impact, response, recovery, and preparedness of the architecture, engineering, and construction community in regard to the coronavirus pandemic. These talks also have brought issues of social, economic, and environmental justice to the new normal post-COVID-19 AEC world. Today marks the final lecture in this series, but acknowledging the aspirations and discussions that started 19 weeks ago, we are happy today to announce a new lecture series starting next week, specifically addressing issues of social justice, but more about that later. Our speakers in the series ending today were from Beijing, Boston, Chicago, London, Los Angeles, Paris, Sao Paulo, Porto Alegre, Seoul, Washington, D.C., Wuhan, as well as New York City. They all addressed the experiences of their offices in relation to COVID-19 impact, response, recovery, and preparedness. We have heard about public buildings, civic infrastructure, COVID-19 medical facilities, and changes in office operations. They all addresses their experiences of their offices. And they also, I would like to thank the organizations with whom we are collaborating in presenting these lectures today. They are the American Council of Engineering Companies, New York. I would like to thank Jay Simpson. The American Institute of Architects, New York chapter. I would like to thank Ben Prosky. The American Society of Civil Engineers. I would like to thank Tom Smith. The Consortium for Sustainable Organization. I would like to thank Lance Brown. The Construction Management Association of America, New York and New Jersey. I would like to thank Vinny Fakowski. Engineering News Record. I would like to thank Jan Tuckman. And the National Academy of Construction. I would like to thank Dwayne Crew. Today, after last week's very timely presentation by Dr. Karthik Chandan on the use of wastewater systems analysis to document and predict COVID-19 occurrence, we return to our discussion of the future, and specifically the future of our cities and our infrastructure as seen through the lenses of the Future World Vision Project of the American Society of Civil Engineers. Our speaker, Gerald Buckwalter, Chief Operating Officer and Chief Strategy Officer of the AEC, will talk about the work of the task group which put that report together. My co-moderator and the respondent today is Terry Niemeyer, the chairman of the board of KCI Technologies, one of the larger 100% employee-owned engineering firms headquarters in Baltimore, Maryland, with 34 offices in 15 states in the Mid, South, North Atlantic regions and Texas. KCI has over 1,500 employees and over $231 million in annual revenues. It's currently the 67th largest engineering firm in the United States. Terry and KCI are committed to sustainability, and he's a past board member and the chairman of the Institute for Sustainable Infrastructure and is an MVSP. In 2009, KCI was awarded LEED Gold level certification for the headquarters in Sparks by the USGBC. This state-of-the-art 120,000 square foot building uses 50% less water and 30% less energy than a traditional design building. He is the past chairman of the Maryland and Baltimore County Chambers of Commerce and past chairman of the American Council of Engineering Companies. Currently, he is chairman of the AEC. He was the chairman of the AEC Industry Leaders Council and has served the board of AEC and the U.S. Chamber of Commerce. He earned a BS in Civil Engineering from the University of Delaware and an MS in Environmental Engineering from Johns Hopkins University and an MBA from Wilmington College. He's a registered professional engineer in 6 states. Thank you, Terry, for being with us today. The speaker for today's program is Gerald E. Buckwalter. Jerry is the Chief Operating Officer and Chief Strategy Officer of the American Society of Civil Engineers, where he's responsible for helping shape the society's strategic direction and operational effectiveness. Among his key early responsibilities is the continued oversight of AEC New Future World Vision project. He also oversees several areas of internal operations, including finance and administration, engineering and lifelong learning, and human resources. Jerry brings more than 35 years experience leading the development of strategies and solutions in multiple organizations with diverse missions. Most recently, he worked for Northrop Grumman, where he served in several capacities, including Director of Corporate Strategy, Information Systems, and Business Development, and as Vice President of Homeland Security. During his decades of experience working in the infrastructure sector, Buckwalter served in various appointed roles on the National Infrastructure Advisory Council under both Presidents Barack Obama and George W. Bush. He's a member of the board of the Center for Public Policy Innovation and has also served on the board of the National Homeland Defense Foundation and the Executive Committee of Virginia's Institute of Defense and Homeland Security. Jerry has been member of the AEC Industry Leaders Council since 2009. In 2018, he received the AEC prestigious William H. Wisely American Civil Engineering Award. He also was named as one of the ENR Newsmaker this year. So we are very proud of Jerry. To learn more about our speaker and co-moderator, please visit the CBIPS website. Jerry, thank you for being here with us today. The screen is yours. Michael?
Thank you very much. I'm pleased to participate with you today and to present our Future World Vision project. The American Society of Civil Engineers wanted to be thought leaders in looking at the future, and we wanted to look far enough into the future to ensure we didn't just extrapolate a view of the future that was not much different than today. That's what we often do. So we started with research in future trends and a classic future scenario analysis. That has been completed. And now we are creating a computer model by which we visualize those results. Today, I'm going to show you and share with you several elements that show the current status of that project. If I could have the next slide, please. There are a large number, actually, if we can go back one. There we go. There are a large number of and variety of global changes coming our way. They are hugely interconnected. We've experienced lots of change in the past, but it's rare to see this many vectors of change impacting us in a relatively short time period. And by that, I mean even a 50-year time period. Everything from technology, such as automation, autonomy, and the Internet of Things, to alternate energy, climate change, demographic changes, smart infrastructure, and new materials, all of which will impact the built environment. We are also creating multi-dimensional ways to look at it, various layers or lenses, so that it's just not another version of a SimCity game. Next slide. These dimensions allow us to examine the energy construct, the transportation systems, the water and wastewater elements, and so forth. That's how an engineer can provocate about how useful today's designs are for future problems. And more importantly, things that we do now that in fact are not good solutions 50 years from now. That allows us to take the right steps toward life cycle resilience with both the present and the future properly considered. Next slide. And we never look at any dimension or trend in isolation. I mentioned how these trends converge, so I show this slide to remind ourselves that we should never look at any trend in isolation. This is a graphic from one of the scenarios we analyzed to help think through the multidimensional convergence and cascading impact and cause and effect that keeps happening among all these trends. We've embraced a very holistic perspective. Next slide. The research yielded a few key transformational imperatives that engineers need to embrace in order to design and build the desired future built environment that's plausible in 50 years. I'm going to point out just a few of these. One, the world is focused on climate change. Very important, huge impact, but changes in demographics and urbanization patterns will have an equal, if not greater, impact. Two, we will be dealing with a world that is digital in everything, which creates the world of autonomy, AI, and so forth. Three, we won't know exactly what technological advances will specifically occur, but we can be sure that there will be things like quantum computing, synthetic biology, and new materials. Lastly, the fourth industrial revolution represents the nexus of all these trends, which will force us to understand system dynamics. Now, while much of the future built environment will not be apparent for many years to come, the first steps should be taken now to prepare for it. If we wait for the nature of our future infrastructure to become obvious, it will be too late to optimize society's use of it and our risks to build it. Next slide. Next, we need to create the stories that reach the heart and mind of all of us. I discovered a long time ago that most people aren't nerdy like me. They don't want to read a 300-page report. We have to have a way for a common understanding. So the Future World Vision Project will create an immersive environment with evocative visuals, characters, and narratives. We want everyone to really imagine 5 communities of the world 50 years in the future, all designed to be radically different and provocative. So we're creating these virtual worlds from a very macro citywide view right down to a neighborhood view, so the users can really begin to understand how they will live. And engineers can explore, collaborate, and consider how they can make the future a better place to live. Next slide. These are the 5 city worlds we selected. They will emerge and evolve in this approximate timeline, and the ones further out on the right are obviously more speculative than the ones that emerged sooner. The chart shows just a few of the ingredients that help us create these future communities. In addition to speculation based upon our research, we also model innovations from a variety of disciplines and a few relatively unpredictable disruptions. This is how we take a view of the future that is not a prediction of the future. We're not attempting to do that. It's a tool by which we ask ourselves the questions about the future so that we are not surprised by those unexpected conditions if they occur, or caught off guard in having prepared for them. And yes, for those who wonder, we did consider a highly infectious global pandemic back in 2018 when we started this project. Next slide. I'm going to now play a short video that we have that describes the Future World Vision project. You can go ahead and run that video. To take a look out 50 years is not typical. But we felt with so many changes, we had to free ourselves from today's constraints and take a step out that far. We're here to create a professional tool rooted in a future that's highly plausible because we're doing deep research with renowned experts in their field. Because 60% of the world's population live in coastal areas, we're starting with the floating city. Engineers have built nations over thousands of years. Now we will need to become masters at systems integration. This is going to be a very exciting ride. Okay, next slide. To take a look out 50 years is not typical. Okay, the current activity is focused on creating the next one, the megacity. Looking at the implications associated with massive urban density and the quality of life for those who live in it. This is the one city where we will also take a very deliberate approach to preserving and/or updating existing infrastructure, since the foundations for megacities lie in the existing large cities of the world. With the megacity, we are currently fine-tuning our different lenses. We will visualize different communities within it, but we will also have differing granularity levels, from a systems view to a district view to a street view, right down to a building view. At various locations among the districts, we will have what we call core samples, where the user can drill down to very specific information on the various components of that sample, which is where the various engineering disciplines can obtain more nuanced research and information. Next slide. Research for the megacity is conducted primarily on the phenomena of today. We take the real-time data from various cities around the world and combine those in a mix to make up our megacity. By doing so, we ground our starting position in the real world as much as possible. Next slide. We have another key snapshot at the 25-year point in time based upon informed speculation. This speculation is still rooted in the data we gather on current research, advancements planned or speculated on by the broad infrastructure community, future architectural designs, and testing laboratories, testing plans of laboratories around the globe. Next slide. And then our long-term vision is driven to a great extent by fundamental science advancements projected in 50 years. As you can see by the images, it's driven by projections in biology, synthetic biology, chemistry, and materials science, all guided by forecasted future end states related to big data, autonomy, nanosensors, and so forth. Next slide. The megacity will also show progression over time. But in the megacity, that progression starts with an existing city ecosystem. So this beginning point should look quite familiar. Next slide. Much of the future city landscape then builds layer upon layer from that starting position. This is the one feature that will remain unique to the megacity. We have deliberately chosen not to treat the megacity as a greenfield type of development. Next slide. An example that is more of a greenfield development is our floating city. So I'll use some of that material to show the evolution of a new community. If we just describe the floating city 50 years from now, it would seem like science fiction. So we take incremental snapshots showing the evolution of the city. We show the horizontal expansion and growth of the city and the vertical expansion above the water surface, subsurface, and on the ocean floor. We also show the evolution of the types of structures that get created to enable a viable self-sustaining floating community. Those structures support essential life-sustaining needs such as power, housing, food, water, and transportation, but they also support entertainment, education, the arts, and cultural events, albeit those happen over a longer period of time. Next slide. Large cities, in our megacity as an example, are not homogeneous. There are clearly downtown centers, industrial hubs, green space, and so on. The nature of those differing city elements will change over time, but the existence of a variety of communities within a megacity will still be a fundamental premise that we retain. Next slide. We will demonstrate that by having 6 different districts in the megacity. They are shown in these images. Some will be familiar. For instance, the regenerative community is a decaying area of blight in the city of today that is reconstituted to become a vibrant part of the new city. We will simply envision how that might happen differently. On the other hand, some districts may be less familiar. Our adaptive corridor, industrial and tech center, and energy and agricultural sector combine elements of technology, education, transportation, and community and personal life in relatively new patterns that are currently less familiar to us. Next slide. As we develop the megacity, in fact, as we develop all our future cities, we have 2 overarching themes that infuse every element of what we do. The digital and virtual worlds will join the analog and physical worlds. The merging of those worlds will continue unabated, despite some hurdles yet to be cleared. And the principles of circular economies will be universal. So we explore everything from resilience to sustainability, to consumption, to regenerative reuse, to social equity. Next slide. At ASCE, in fact, we are uniquely focused on resilience and sustainability. We create vulnerability assessment tools for the entire development community, which can definitively reduce the risks associated with the built environment due to disruptive events and conditions. Secondly, we are developing a rigorous global engineering standard for sustainable and resilient infrastructure. Not a guideline, not a set of principles, but a true engineering standard that can be used in infrastructure design and in which engineers can be certified. These tools go a long way to helping de-risk every phase of an infrastructure project and achieve our ultimate resilience goals. Much of our infrastructure is a long life cycle asset, so we need to design them with a 50 to 100 year use case in mind. Next slide. In order to give everyone a better feel for using Future World Vision when we complete it, I will use an early version of the floating city that we displayed at the ASCE annual convention in Miami last October. So for those who weren't there, this is a short 2-dimensional excerpt from a three-dimensional experience using the virtual reality goggles. Go ahead and play that, please. Okay, the feedback that we've received regarding this project has been overwhelmingly positive and indicates that the Future World Vision participants really do understand the cultural change. No, let's go back. And basically we're gonna have some excerpts here from the interviews at the convention so that we can kind of demonstrate participants' understanding. Go ahead and play that. Today represents the 9-month mark in a 4-year development project, by which civil engineers and many other engineering disciplines will be able to talk together to start thinking about how to solve tomorrow's problems.
We call this a provocation machine. It is designed to create a new kind of thinking in the younger generations. Many of the older engineers, of the really well-established engineers, are the ones who are most excited about this.
If you go out on the floor, you will see engineers in their 70s and 80s with VR goggles on saying, wow. And right next to them, an engineer in their 20s who's saying, wow.
This isn't looking at a plan set or some technical diagram. This is an immersive experience. It carries a wow factor and a sense of understanding.
I was kind of scared at first. I'm scared of heights, and so I didn't realize that I was going to be feeling the feelings that I would feel in the real world through the VR experience.
When it went underwater, I literally was weak in the stomach. It felt that good, the graphics were that good, and the movement was that real to me. It more than exceeded my expectations. And the use of this technology will cement the civil engineering industry as being on the forefront of innovation.
So I teach at a graduate level, but also do outreach to high schools and grade schools. And so I think this would be a great tool to allow them to get excited about what's going on in engineering.
In my 37 years of membership at ASCE, this is the most inspiring, motivating thing. I can't wait to share it with other people in our industry. The validation that the imagination that every engineer uses all the time. The fact that you can put this into a VR virtual reality format and let everybody live your imagination is fantastic. And we can build it together. It's so exciting.
This is going to allow us to get ahead of the game.
The sessions that we run at this conference are designed to inform, but they're also designed to be a massive market test, if you will. We're really looking for the feedback. We can take that feedback and make sure our end product is as fine-tuned as we possibly can.
So far we've developed the floating city from 2030 through 2050.
Oh, I think there's huge benefit to having everybody working together.
You can be critical or you can be supportive of ideas that are inside this space. Any contribution you make is going to change the space. There's this great opportunity that goes beyond collaboration. It goes into partnership for change.
Someone says something, The next person takes that thought and carries it to another point. It comes back and keeps growing and expanding on itself. That's the benefit of collaborative group effort.
And whatever we can imagine, we can create.
The Future World Vision will help drive us forward in multiple ways. It's going to attract the engineer of tomorrow, but it's also going to get us out of our space, out of our codes and standards where we typically practice, and make us think, well, what do I have to build if that's the future?
If we continue to collaborate, we can build something that is very robust and that allows the members of ASCE to contribute to the vision that we all would like to see.
The value of this tool is to benefit civil engineers right now. When you see change coming, infrastructure has to change with it, because believe it or not, we have clients who are already thinking about those things. Okay, next slide. There we go. We believe the Future World Vision project can have a great impact on our industry and our profession. We think it has the potential to help us make progress toward those transformational imperatives that I previously spoke about: promoting systems thinking, taking a multidisciplinary approach, creating a common collaborative platform for everyone, exciting the next generation, and sparking innovation and creativity. Next slide. I do want to extend my thanks to the many academic institutions that have already hosted Future World Vision events and presentations. And of course, my special thanks today to Columbia for giving ASCE this opportunity to share our journey and to help shape the industry to be prepared for what society needs from us now and in the future. Next slide. Our hope is that those of you who help us optimize the Future World Vision project will be among a global network of academic institutions and practitioners that help engineers become the systems-oriented thinkers, designers, and builders that create the future infrastructure we desire, including the radically different future built environment that's possible. And over time, we can create a future planning tool, an environment that's constantly learning and evolving among global universities, research centers, and all vested organizations. That is the long-term goal for this project. Next slide. Thanks for giving me time today to present the Future World Vision project. ASCE is committed to being an active collaborator, an ally to serve city governments, urban planners, communities, and all vested partners. I think the engineer can no longer simply say, tell me what you want me to design and build. That is not an effective way to manage the conditions of the future. Engineers have a significant and unique perspective and input into creating the infrastructure that will serve the intended purpose, be resilient, enhance public safety, restore the environment, preserve culture, and create an equitable society. Thanks very much. And I think, with my apologies to Terry Niemeyer, who I featured as an interviewee in the video without warning him, I will go over to you guys for Q&A.
Great. Thanks, Jerry. We appreciate that. And yeah, I didn't know I was going to be on TV, but it was good seeing me. Jerry, we wanted to let people know that, if you want to submit questions, just submit them through the chat box, and we'll try to get them in the last 15 minutes of our presentation here. But we had a question to kick off the thing. And again, Future World Vision, it looks like it was done by a group of professionals. I'll even suggest Hollywood type of professionals to develop such great products. And can you share with our audience who the professionals were in developing this product?
Sure. So I would say that's half right. We used two major consulting firms. The first one was Altman Villandry and Company out of Boston. I have used them many times in the past in my former lifetime to do very rigorous, very disciplined future scenario analysis. They're a unique firm, one of the best in the world at doing that in a very disciplined, deeply researched way. Most of us do future scenario analysis by having a lot of smart people sitting around the table and we just come up with ideas, but sometimes it's not well grounded in really thoughtful research. And so we use them to get us started. Now we're moving on to this computer model, and that consultant is a Los Angeles-based firm called Experimental. It is founded by Alex McDowell, who, for those who may remember it, is a Hollywood production designer, worked mostly on Steven Spielberg movies. And one of his major movies was a film called The Minority Report, which is the first movie ever done where they gave the production designer the opportunity to create what a future world looked like, which he spent 2 years doing before they ever wrote one word of the script. He then did similar things for Hollywood and ultimately decided that this world building kind of activity had so much more value than just for creating movies, and started his own design firm who does these kinds of imagining plausible future realities for a living, mostly for corporate and government clients now.
Thank you. And thank you, Jerry, for this wonderful presentation and kind of telling us a little bit of the planning that is going on to really think about the future. And thank you, Terry, for participating on this and bringing your experience. And we also saw your kind of Hollywood debut. So it was really interesting. We have a couple of questions that relate to this planning of the future world vision and the pandemic. And the question is, like, during the development of the future world vision, one of the uncertain and complex issues for future infrastructure engineering was a scenario of an uncertain future, events like the pandemic. Can you tell us the benefit of this type of planning and how it could help us for this very unpredictable situation that we encounter ourselves in?
Sure. So as I mentioned in the briefing, we did include what we typically call low probability, high consequence events. And we had a whole selection that we debated. And in fact, we picked 3. One was a global pandemic. One was a worldwide food supply disaster from a GMO failure. And one was a nation state regime change that would cause nationwide violence, global violence. So those were the 3 we picked out of several we could have picked. Again, we're not predicting those things, but by adding elements of that into our future scenarios, it allows us to consider some of the elements of our typical current approach and whether they hold up well under that. So, for instance, when we started this in 2018, we had taken a look at the phenomena of demographic and population migrations, which is hugely into an urbanization pattern in most countries, and what would happen under those circumstances under a pandemic. So obviously, lo and behold, here we are, and we had explored phenomena like, well, for instance, let's take transportation, that in fact, most people would abandon mass transit, and yet megacities are dependent on some future sort of mass transit. We explored elements like what would happen to societal unrest and counteractions by the public. We had explored what you could do with mass transit by which you could create personal isolation and distancing, things that we quickly discovered and went to, for instance, one door for ingress, one door for egress, and social distancing on those platforms. Now, here's what's amazing. That was our view in the first 10 years. If I looked out 50 years, or 25 years, let's say, we actually looked at more individualized compartments. All of the individual vehicles in mass transit would actually change. If we looked out 50 years, we were actually looking at wearable fabrics that were antibacterial and antiviral. And in fact, all of those other measures could go away because now people could be closer together and still be safe. So it's a way to explore. That's just a transportation example, but it's a way to explore, if you're designing transportation, how do you think about the life cycle of that under different materials, different pandemic conditions, and what might be good now might be very different in 25 years and might be even more different in 50 years. Again, these things are designed to last that long, so why not consider that as you look at what you do now? So we obviously looked at that. We looked at the kind of remote working, now the work from home phenomena, and high-speed mass transit that would make decentralized living more attractive at much greater commuting distance than we currently experience if you had true high-speed hyperloop type transit. And of course, the whole world pretty much fully connected and virtual, which we, of course, discovered was much easier to go to once the pandemic hit than we ever thought it would be. So it allowed us to explore those in advance. And what you discover in that process. Now here's an interesting thought experiment. What would that similar phenomena to be like under a global food supply disaster? Might be the same, might be very different. When you deal with future planning, I discover that I become a bit of a historian as well. I often, my wife tells me, you have trouble living in the present. It's the future and the past you got nailed. If I take a look at a global pandemic, it's only low probability from a snapshot in time. If I look at a several 100-year history, the probability of a global pandemic is extremely high, almost 100%. If I look over a 1,000-year period, a global food shortage is nearly 100% phenomena. What we don't know is the timing. So these kinds of exercises allow you to weigh those things. Not that you can plan for all the solutions because you never know the timing, but at least you won't be caught by surprise. We will have taken some time to think, and therefore will respond faster. That's kind of my pandemic example, but it's just one of many where this kind of scenario planning can really help you think through those things.
Thank you.
Great. Jerry, I got a question that I developed here for you that talks a little bit about this. So Jerry, ASCE has made this major investment. And so the question comes about that says, so what? You know, what's the big deal? And again, my question is that, you know, we already have one of the predictions coming true in COVID, and many experts are predicting a second wave of COVID potentially this winter. Can a tool like this help infrastructure owners and operators adapt to a new environment better and be better prepared? And can you elaborate on that for us a little bit?
Sure. So I think one of the practical things that we should look to try to do on a second wave or any subsequent is to simply get engineers, the problem solvers of the world, engaged in cross-disciplinary conversation at a community level, at a city level, at a national level. And I think this is the tool that can help us. I'll use, bear with me just a moment. And I'll explore personal opinion here. COVID launched in our country and everywhere around the world. Every day we watched the conversation on TV, and it was dominated by two things. Epidemiologists who talked about how the disease was likely to spread, and as they learned better, it changed a bit, and that's perfectly fine. And what I'll call the healthcare behaviorists, the healthcare sociologists. How do you incent people to do the things that would protect them? That's a good conversation. But where were the engineers who could talk to not just the social science of public life and the medical issues, but what are the elements of practical day-to-day living that problem solvers have solutions for or can dig in and provide solutions for? Finiaski, you mentioned one of the series that you've already featured with wastewater, a COVID detection through wastewater. I heard that conversation from at least 3 universities all the way back in February and March. Relatively simple, relatively inexpensive. In the early days of COVID, it could have identified which communities were nearing community spread in advance of any symptoms forming. Therefore, we would have been able to smartly lock down or socially distance in the communities that needed it before any symptoms showed up, and we wouldn't have to interfere with life in those that didn't have it. And guess what? It was a conversation just between engineers. It wasn't where engineers had a seat at the table with the epidemiologists and the virologists and the healthcare people to say, what's both the, not just the restorative or restorative elements of COVID, what's the preventive ways for everyday life to continue, and what are our options? My hope is if you use a tool like Future World Vision, you can think through that kind of those kinds of engineering solutions, potentially. You have a tool to collaborate with a government policymaker or urban planner or healthcare official, becomes a translation machine, if you will, so that you can then have that conversation and understand each other, and maybe then engineers have a way to make this both a preventive and a restorative conversation on the next wave, with examining all sorts of things that now we see everybody scrambling to do, non-touch opening of doors and means of transportation and protective face gear. But you know, that should be part of the policy discussion. This is a tool, I hope, that gives engineers a seat at the table, so we have a more comprehensive conversation about such complex issues.
Thank you, Jerry. And this is incredibly thoughtful. And like you're saying, you know, that conversation in which engineers could be part and add so much to it. And one of the things that you mentioned when you were talking about the Future World Vision is the ideas of the 3 scenarios that you look: the pandemic, the food supply, and the social unrest. But one that we have been hearing quite a bit, actually pre-COVID and now even during COVID, is the issue of water supply, drought in different parts of the world. And then if you combine that with pandemic and social issues, which now in the United States, at least we have the confounding effect of the pandemic and the social component. And in some states, you know, because of the lack of rain, the lack of snow, there have been imposed limitations on water usage, and that can affect crops and can affect day-to-day life. How do you see all these coming together, looking at multitude of the scenarios playing together, and how do we prepare both as a professionals, but also for the students that are part of this lecture series that are looking like, okay, where is the future? What future am I going to be practicing when I graduate and start working? I know it's a convoluted question, but I don't know if you can bring some of this together.
So again, I'm going to make 2 points. One, we're used to, again, I know I get a little nerdy on people, but you know, look at the last 100+ years. We're used to specialization. It has achieved in the last 100 years amazing advancements in medicine and engineering and science, but in the process, we've had an unintended consequence where we always rely on a specialist and we have less holistic thinking of complex issues. We need some people who embrace the complexity and are willing to look across. So I think an exciting thing for the next generation to think about is, what's your specialty? Could be water, could be environmental, could be geotech, it could be any number of things. But everybody should embrace the complexity of holistic thinking, because solutions are always holistic. There's just this cascading ripple effect in everything. I think the next generation embraces that way of thinking. You know, if you're an old guy like me, you just call it a return to common sense of my grandparents, but it's really a systems orientation. 2, water is a ubiquitous challenge and will emerge differently. So in our next city world, we call it the rural city, that will be hugely water and agriculturally focused, not just because we want to talk about that relative to our classic Midwest phenomena, let's say, which is really important. But on that one, it's also merging what you explore in the way of not how you survive a drought, okay, but how do you thrive under, you know, modified climate, under modified agricultural conditions, and have a thriving community in a segregated way, because that's the logical option for those who don't want to be in a megacity. And the two actually work together. So you got to look at the food supply issues between the two as they, you know, align. And in that one, we also hope to make sure that with the rural city, when we raise our next bunch of round of funds, that will be our 3rd one that we launch, we will also expand it so that we're treating it in a way where it can represent the global South as well. If we're going to deal with water issues and sustainability issues globally, you have to attend to the global South, the developing world. And so that's the one city world we're going to take a very intense focus on making sure we can speak to the global issues with that agricultural and water bent focus as well.
So Finney-Aska, do we have time for a question, or are you want to wrap up? You tell me.
I think I will have to wrap up. Is that okay?
Sure.
Okay, so I just want to again thank Terry and Jerry for such a wonderful discussion. Thank you, Jerry, for, I remember you saying the whole notion of you being the chief provocateur, and I think you live to that image again today, in which you brought the issue, and again, talking about how the engineers have to take a leadership role in all these very important.
You are kind. Most people just call me a troublemaker.
A troublemaker. Thank you. And I also would like to thank Terry for his very insightful questions and conversation. Thank you both for participating. I also would like to thank ACEC New York, AIA New York, ASCE, CMAA New York, New Jersey, CSU, ENR, and NAC. I also would like to thank our past speakers and past co-moderators who have joined us today. We have Wayne Crew, the General Secretary of the National Academy of Construction. We have Eric McFarland, Deputy Commissioner for Infrastructure at New York City Department of Design and Construction. We have Jan Tuckman, Editor-in-Chief, Engineering News Record. Linda Tom, Chief Architect, the Chief of New York City Transit. Thank you all for participating. I also would like to thank all of you out there in offices, agencies, and at home, both in New York City and around the world, for taking time to listen today. Continuing education credits for architects have been requested. If you are seeking credit, please send your name by email to cbips@columbia.edu. I also would like to thank the team at Columbia Center for Buildings, Infrastructure, and Public Space. Michael Smith, hey Jan, how you doing? Charles Chen and Rick Bell, I can tell you that without them, none of this will be possible. As you can imagine, we are starting our new academic year and everybody is trying to juggle a lot of different balls at the same time. So I really appreciate all the work and all the contributions, and thank you for making this lecture series such a success. Starting on Tuesday, we are starting a new series on September 22nd at the same time, 12 to 1, in which we will focus on these issues of social justice as it relates to the AEC industry. Our first speaker is Justin Garrett Moore, the Executive Director of the Public Design Commission of the City of New York, and a leader of the Black Space movement, looking at some of the issues that we have been seeing playing out in the news and in discussions in our offices, at home. And I think it's going to be a very interesting. This series is going to go for 8 lectures of 1 hour and 1 lecture of 46 minutes into November. And we will invite both leaders from the public and the private sector, discussing issues both from business side, human resources side, as well as how do we modify our communities to make it more socially inclusive. On our website, cbips.engineering.columbia.edu, you can find information about our past lectures, including the PowerPoint presentations and video recordings of the talks. You can also find information about upcoming lectures in the program, like the new lecture series in social justice in the AEC industry. Also added to our website are thoughts about the reopening of workplaces, in addition to ideas about the reopening of restaurants and bar spaces. So thank you all again for joining us today and throughout the series, and please stay well, stay safe. Thank you so much for all your participation. Bye.